Sometimes field research isn't much fun. German scientists have come to Bangladesh to test a new biosensor for detecting arsenic. The head of the project is due to arrive later this afternoon. But first, the researchers have to dry out. These are the team's first impressions of Noah Para, about a 2-hour drive away from the country's capital, Dhaka. The village of 4,000 has a serious arsenic problem.
It's a little bit getting less, then we take some samples and we test here.
Okay.
Yeah? But we have to wait a little bit.
Fortunately, the shower passes quickly. The scientists can now get out and start setting up the biosensor equipment. The test developed in Germany is inexpensive and doesn't require any toxic chemicals. Instead, it relies on genetically altered bacteria. The microorganisms can be used to check water for traces of the deadly poison arsenic.
These bacteria possess a natural mechanism for removing arsenic back out of the cell, because arsenic is also poisonous to bacteria cells. We took advantage of this shunting mechanism and built in a tiny light switch. And that means these genetically modified E. coli bacteria begin to glow when they come into contact with arsenic.
Geologist Konrad Siegfried sets out to collect new water samples. The test wells he's taking them from vary in how long they've been used, their depth, and their location.
Right now, we're taking the coordinates of the wells so that later we can say there's a higher concentration of arsenic in this or that area at this or that depth.
Most of the families of Noah Para have their own wells. They were dug to provide an alternative to pond water, which can carry cholera or typhus. But the water from the wells often contains arsenic.
My father-in-law died of arsenic poisoning 6 years ago. The well was tested afterward, but we never received any real results. Now we have no idea what to do.
The invisible toxin can be found in the ground in many countries in Asia. It dissolves in the groundwater that is drawn up from the wells. Exposure to the naturally occurring environmental poison first makes people chronically ill. Mohammed Asanullah is one of them. For years, he unknowingly drank well water contaminated with around 800 micrograms of arsenic per liter, around 80 times higher than what the World Health Organization says is safe.
For about 2 years, I've been incontinent in bed. I can barely sleep, and everything is painful. When the sun shines on my body, it burns. And if I pour cold water over my head while washing, then I feel hot all over.
The changes to his skin are only the outer signs. The poison has done far more damage to Asanullah's other organs. The government has now installed an arsenic filter in his well, but he doesn't know if it works. He has no way to test it.
If he continues to drink contaminated water, then no one will be able to help him anymore. The poison will do even more damage to his internal organs. He'll develop cancer that could attack his liver, bladder, or kidneys, and that will kill him.
Back at the village square, microbiologist Carola Endes shows us the test that could enable local aid organizations to finally perform large-scale safety testing in villages here. These glass vials contain freeze-dried bacteria. When water samples are added, the biodetectors come back to life. The amount of light emitted by the bacteria is checked 2 hours later with an instrument called a luminometer. The glow provides key information about arsenic levels. In the lab, the system works perfectly. But out here in the field, it has been giving some false readings. The researchers are still trying to figure out why.
For one thing, the sun can be stronger from one day to the next here. In other words, temperatures rise, or the humidity changes, or the water has a different composition than we're used to. All those factors could affect the test. We have to figure out which ones are doing that.
That's why 8 samples are taken from each well. To ensure that the results are accurate, Konrad Siegfried also carries out chemical tests. The team will take the other 6 samples back to Germany with them for more extensive observation in their lab at home. The village residents are following the experiment with interest. They invite the researchers to test more of the wells. Arsenic is so much on people's minds here. There's even a song about it. Listen, listen, she sings. The arsenic in the water will kill you. Don't drink it. But many here don't know whether their water is contaminated or not. You can't taste arsenic or smell it, and only a tiny fraction of the 10 million wells in Bangladesh have been examined to date. That's why a cheap test is so important, say local scientists.
Here is a tube well, and then just a few meters away another tube well, but one is contaminated, one is not. And there is a chance that the one that doesn't have the arsenic can have the arsenic again. So it's not that you do the testing once in 20 years and say, okay, it's without arsenic. But you have to do that in an interval. That has to be found out.
Later that afternoon, the head of the research team arrives. Hauke Harms was instrumental in developing the new bacterial test. Now he's checking on progress out in the field. Harms sees the biosensors in the vials as just a starting point. In the coming years, he wants to make a test strip for wells that even an untrained person can use.
So etwas können wir auch machen.
We could make something like that. We could genetically modify bacteria to change color when you add arsenic into reactive agent. Usually a solution like that would turn a blue color. Then you could interpret it with the naked eye.
Und die kann man dann mit bloßem Auge interpretieren.
Developing this kind of test strip will take about 3 years. But according to Harms, biosensors can do even more. For example, they could theoretically detect arsenic in food as well. No one knows how much of the poison ends up in the country's main staple crop, rice.
Ich würde schon gern den
I'd like to be the one to prove that biosensors are ultimately superior to chemical analysis. That's a dream of mine. To improve them so much that chemical analysis, as it's practiced today, becomes a thing of the past.
wie sie jetzt betrieben wird, vergessen machen kann.
In the evening, the team meets to discuss the events of the day. The results are encouraging. The German researchers will continue the work, both in Bangladesh and in the lab back home. By the end of 2011, they hope to have reached their goal, a test for arsenic that can be used throughout Bangladesh.